Claude Opus 5 did not get smarter. NVIDIA did not secretly swap in a better model, and yet the same model went from about 30% to 100% on the public ARC AGI 3 environments. That should make every developer who pays for premium AI stop for a second, because the obvious lesson is not that Claude is magic. The obvious lesson is much more uncomfortable. You might be spending money on the wrong part of the system. Everyone wants the smartest model, the biggest context window, the newest reasoning mode, the model picker option with the most impressive name. But NVIDIA just made the opposite argument look painfully real. Maybe the smarter buy is not another model upgrade. Maybe the smarter buy is a better harness, better memory, better feedback, better retries, better supervision, better ways to stop the model from wandering in circles and charging you for the privilege. That is the part people keep underestimating. An AI agent is not a brain in a jar, it is a brain inside a machine. And if the machine is dumb, the brain wastes itself. So this is not a video about a benchmark victory. This is about why the next expensive AI mistake will be buying a smarter model when your agent still has no memory, no manager, no useful loop, and no way to learn from its own mess. Because after this NVIDIA AVO result, one thing is getting very hard to ignore. The harness is becoming more important than the model. Hey, don't forget to like and subscribe for more like this. Now, back to the video. Here's the number that matters. ARC Prize reports Claude Opus 5 at about 30% on ARC AGI 3 at high reasoning effort. That was already a strong result. On this benchmark, 30% is not embarrassing. It was the top model result. ARC AGI 3 is not a normal question answering test where the model reads a prompt and writes an answer. It drops the system into small interactive game environments with hidden rules. No friendly tutorial, no manual, no obvious statement of the goal. The agent has to poke the environment, watch what changes, infer the rules, remember what worked, stop doing what failed, and keep moving. That is why the number is interesting. A chat model can sound smart in one answer and still be terrible at a long sequence of trial, feedback, memory, and recovery. That is the difference between answering and operating. Then NVIDIA wraps Claude Opus 5 inside AVO, which stands for Agentic Variation Operators, and NVIDIA says that full AVO agent system completed all 25 public environments, all 183 levels. A 100.00 RHAE score on the public set. Now there is a caveat, and it matters. NVIDIA explicitly says you should not treat 30% to 100% as a clean, controlled ablation. The baseline and the AVO setup differ in more than one way. Different agent backend, different observation format, different memory, different context management, different execution loop. So if somebody tells you this proves AVO alone added 70 points, they are overselling it. But if somebody tells you the result does not matter because it is not a perfect lab comparison, they are missing the story. The story is that the model did not define the ceiling by itself, the complete system did. That is the part that should change how you think about AI coding tools, because most people still talk about agents as if the model is the product. It is not. The model is an ingredient. The harness decides whether that ingredient becomes a meal or an expensive puddle. The easiest way to understand this is to imagine two developers using the same model. Developer 1 opens a chatbot, they paste an error, they paste a file, they ask for a fix, the model guesses, they paste the next error. The model guesses again, developer 2 uses an agent with a real harness. It reads the repo. It finds the failing test, it edits the right file, it runs the test, it notices the new error came from a fixture, it records the failed attempt. It tries a narrower change, it asks a stronger model only when the cheap path is exhausted, it checks the diff, it explains what happened. Same model, different machine, different result. That is what a harness is. It is the surrounding system that controls what the model sees, what it can do, what it remembers, how it gets feedback, and how it decides what to try next. And once you say it that plainly, the obsession with raw model rankings starts to look a little childish. Because the model is not doing the job alone. The model is being aimed, and bad aiming is expensive. If your coding agent keeps rereading the same files, that is not a model intelligence problem. That is a memory problem. If it keeps trying the same broken fix with different wording, that is not a model intelligence problem. That is a feedback loop problem. If it cannot tell when it is stuck, that is not a model intelligence problem. That is a supervision problem. If it sends every tiny task to the most expensive model in the stack, that is not a model intelligence problem. That is a routing problem. And developers pay for all of those problems with tokens. That is why this NVIDIA result hits harder than a normal benchmark chart. It does not just say one system scored higher. It says the expensive part of AI may be less valuable when the surrounding loop is weak. AVO was not invented just to play little games. NVIDIA first used it for long-running engineering search, especially GPU kernel optimization. That matters because kernel optimization is exactly the kind of work where a single beautiful answer is almost useless. You do not win by asking the model for one clever kernel and going home. You win by trying ideas, measuring them, throwing away the bad ones, keeping the good ones, combining partial wins, testing again, finding weird performance cliffs, noticing when an improvement only works on one shape and fails on another. That is agent work. It is not one answer, it is a loop. NVIDIA says AVO explored more than 500 directions in its kernel work and committed 40 versions. That is the important mental image, not a chatbot giving a genius paragraph, a system running a disciplined search, trying, measuring, remembering, supervising, recovering. That is also why ARC AGI 3 is a useful second example. On the surface, GPU kernels and hidden rule games look completely unrelated. One is compilers and performance. The other is tiny worlds with strange rules, but underneath, they have the same shape. Act, observe, update, remember, try again. Stop repeating the same mistake. That last sentence is where so many agents fall apart. They do not fail because they never had a good idea. They fail because they cannot preserve the useful parts of the journey. They rediscover the same thing. They forget why an approach failed. They drift from the objective. They produce motion without progress. And motion without progress is the most expensive kind of AI because it feels alive while it burns your budget. The supervisor part is the most underrated piece. People love talking about models as if intelligence is just more thinking. Let the model reason longer, give it more context, turn the effort dial up. But long-running work does not just need more thought, it needs management. A human developer has this naturally. When you're debugging, part of your brain writes code, another part of your brain watches you. You notice when you're thrashing, you notice when you have spent 20 minutes proving the wrong thing, you notice when you're changing too many variables at once, you stop and ask, wait, what do I actually know? That watcher is not glamorous, but it is often the difference between solving the bug and losing the afternoon. Agents need that watcher too. AVO has a supervising layer that can redirect the main agent when it gets stuck, repeats itself, or drifts. That sounds less exciting than a new frontier model. It is probably more important because most agent failures are not cinematic failures. They are boring failures. The agent searches the wrong thing, then searches it again, then edits around the real issue, then explains the wrong cause with confidence, then uses more context to become more confident about the wrong path. This is why I think the next wave of serious AI tools will feel less like chatbots and more like tiny teams. One worker tries the task, one reviewer checks the output, one supervisor watches the strategy, one memory layer stores what was learned, one router decides which model deserves the next call. That sounds more complicated than one model. It is. But the point of software is to put complexity in the system so the user does not have to hold it in their head. Right now, too many developers are acting as the harness manually. You paste the file, you paste the error, you remind the model what it already tried, you tell it the test still fails, you force it to stop rewriting everything. You become the memory, you become the supervisor, you become the evaluator, and then you pay the model. Like it did the whole job. That is backwards. This is where the money argument gets sharp. Premium models are expensive because they are powerful. Fair enough. But a lot of agent work is not premium work. Reading a file is not premium work. Summarizing a test failure is not premium work. Checking whether a command succeeded is not premium work. Remembering that attempt 3 failed for the same reason as attempt 1 is not premium work. The premium model should not be doing paperwork. It should be doing the rare turns where deep synthesis actually matters. Architecture, ambiguous trade-offs, dangerous refactors, security reasoning, subtle bug diagnosis, final review. Everything else should be routed, cached, remembered, automated, or handled by cheaper workers. That is the real threat to model worship. Not that smaller models suddenly beat the best model at everything. That is not the claim. The claim is that the best model may be wasted inside a bad harness, and a merely good model may look excellent inside a disciplined one. For developers, this changes the buying question. The question should not be which model is smartest this month. The question should be which system converts model calls into shipped work with the least waste. That is a very different leaderboard. It includes memory, it includes tool quality, it includes permission design, it includes test loops, it includes context selection, it includes model routing. It includes whether the agent can admit that it is stuck before it burns another $10 pretending to think. This is why paying for better orchestration can beat paying for a smarter model, because orchestration improves every turn. A model upgrade improves the model call. A harness upgrade improves what the model call means. That is a bigger lever. There's also a second business story hiding here. Model companies want you to believe the scarce thing is raw intelligence. Tool companies want you to believe the scarce thing is workflow. NVIDIA is making a third argument. The scarce thing may be the agent system that turns intelligence into useful long horizon behavior. That is convenient for NVIDIA, obviously. NVIDIA sells the infrastructure world where more serious agent systems run, so you should read the result with your eyes open. This is not a neutral fairy tale dropped from the clouds. It is a vendor research result. It is on the public set. It is not the private ARC competition. It is not open code you can install today and test in your repo. Those limitations matter, but none of them make the main point go away because the industry is already moving in this direction. Cursor is not just a model picker. Claude Code is not just Claude in a terminal. Copilot is not just completion. Open source coding agents are not just prompts wrapped around API-S. The product is the loop, how it reads your project, how it edits, how it runs commands, how it asks permission, how it remembers, how it checks itself, how it gives up, how it hands control back. That is why two tools using the same model can feel completely different. One makes the model look sharp, one makes the model look drunk, and the model did not change, the harness did. The dangerous part is that benchmarks are going to get messier. For years, people wanted clean model rankings. Model A beats Model B beats Model C. Put it in a table, argue in the comments, but agents break that simplicity. Once a system has tools, memory, planners, supervisors, sandboxes, and routers, what exactly are you measuring? The model, the prompt, the tool interface, the retry policy, the memory design, the hidden evaluator, the budget, the scaffolding? The answer is yes. You are measuring all of it. That makes comparisons harder. It also makes them more realistic because real work is not clean. Real work is the whole system. When your coding agent fixes a bug, you do not care whether the intelligence came from the model weights, the repo map, the test runner, the memory layer, or the supervisor. You care whether the fix works. You care how much it costs. You care whether it broke something else. You care whether you can trust it again tomorrow. This is why the phrase model benchmark is starting to feel too small for agent work. We need system benchmarks. Cost per solved task, human review time saved, number of failed loops avoided, rate of repeated mistakes, diff quality, recovery from bad assumptions, actual shipped work. That is the scoreboard developers should care about. Because a model that scores slightly higher in isolation can still lose inside a bad workflow. And a system that looks less glamorous can win because it wastes fewer turns. So what should you actually do with this? First, stop treating the most expensive model as the default answer. Use the best model where it matters. Do not use it as a broom. Second, judge coding tools by the loop, not the logo. Can it run tests? Can it remember failed attempts? Can it inspect the right files? Can it keep changes small? Can it recover when the first plan is wrong? Can it explain why it chose a route? Can it stop? That last one sounds funny, but it is huge. An agent that knows when to stop is cheaper, safer, and usually more useful than an agent that keeps going until the context window becomes a landfill. Third, pay attention to orchestration features that look boring. Memory task state, subagents, tool permissions, command feedback, diff review, model routing, checkpoints. These do not look as exciting as a new model launch, but they are the parts that turn a model from a clever speaker into a useful worker. And fourth, be skeptical of every benchmark number, including the exciting ones. Ask what was actually tested. Public set or private set? Model alone or full agent? Same harness or different harness? Same budget or different budget? Same interface or different interface? That skepticism does not make the result less interesting. It makes it more useful because once you understand what changed, you can steal the lesson without swallowing the marketing whole. The big lesson from NVIDIA Evo is not that every agent should copy NVIDIA. It is not that Claude Opus 5 is secretly perfect. It is not that ARC AGI 3 is solved. It is that intelligence without process is fragile. Developers already know this from human teams. The smartest engineer on a chaotic team can still ship garbage. No tests, no review, no issue tracking, no rollback plan, no shared memory, no clear owner. Brilliance gets wasted, but a good team with decent process can outperform a brilliant person trapped in chaos. That is what is happening to AI agents. We are moving from asking how smart is a model to asking how good is the team around the model. The model is one member of the team. The harness is the manager, the notebook, the test bench, the tool belt, the memory, and the brake pedal. And if that sounds less glamorous than a new trillion parameter release, good. That means we are finally getting closer to real software. Real software is not magic. It is boring pieces arranged so well that the result feels powerful. AVO matters because it makes that visible. Same model family, very different outcome. Not because the model became a genius overnight, because the system stopped treating the model like it had to do everything alone. That is the future of AI coding. Not one giant brain answering every question. A harness that knows how to spend intelligence. And if you're paying for AI tools, that should be the thing you watch next. Not just which model is on the dropdown, watch who is building the better machine around it. Because the next winning agent may not have the smartest model, it may have the best harness,